Hey folks, I've got a fun circuit analysis example for us. And this one has multiple branches, couple batteries, and we're gonna learn some shortcuts here on solving this. So if you look at this, there are many currents, right? There's a current up here, we'll call that I1. There's gonna be a current there, there's gonna be a current here, there's gonna be a current here, and a current here, and a current here. So that's 1, 2, 3, 4, 5, 6 different currents. So technically speaking, we should have 6 different equations to solve for them. And we're gonna find all the currents everywhere. Um, so it turns out, though, there's a lot of shortcuts. So we're going to start by making some guesses here as to which way the currents go, and we're going to name them. So I will make a guess here that this current will go that way. I'll call it I1. Okay. And then here there's going to be a split. We'll call this I2. And then this current here. Okay. So you could call that I3. However, I know if I use Kirchhoff's junction rule right there, that I1 equals I2 plus this unknown current. So this unknown current must be equal to I1 minus I2. So we'll call that I3, but it's actually going to be, if you solve for it, it'd be I1 minus I2. Okay, so I'll kind of write that up here. I know that we'll call it IX. We know that IX plus I2, that's coming out of that junction, has to equal I1. So IX is simply I1 minus I2. So we're using Kirchhoff's junction rule, but we're eliminating an unknown immediately by using Kirchhoff's junction rule. Okay, we're going to keep doing that. Now we have to make a guess here. We'll call that I3. Okay, so now I've got a junction there. I can write this current in terms of I2 and I3, and this IX plus I3 would be I2. So IX here would be I2 minus I3. So this is I2 minus I3. Looking at this junction, I3 goes into it, and also I1 minus I2 goes into it. So that amount of current has to come out of it. Okay, so this has to be I3 plus I1 minus I2. So I3 plus I1 minus I2. And then you can double check at this junction here. If I add the two currents going in, okay, if you look, the I2s cancel out and the I3s cancel out. Or I'm sorry, the I3s cancel out, and you end up with I1, which is what should be right there, which is what we have. So we had 6 unknowns. We used Kirchhoff's junction rule 3 different times to eliminate 3 of those unknowns. So we're down to 3 unknowns now, I1, I2, I3. But we still need 3 more equations, okay? So now we got to start using Kirchhoff's loop rule. And there's a lot of loops you could pick. You could pick the top loop, the bottom right loop, the bottom left loop, the outer loop. Okay, so or you could pick like a loop that starts here, let's say, and goes like this, and then cuts through the middle. And then you could do another loop that would cut through the middle down this way and to the right. So there's 6 different loops you could pick. We're only going to need to pick 3 of them as long as the 3 loops together cover every part of the circuit. Okay. So the first loop I'll pick is, I'll use the outer loop. Okay, now remembering that I'm just using V equals IR. Okay, if you're going with a current, it's a drop in voltage. If you're going against a current, it's a gain in voltage. If you're going through a resistor. If you're going through a battery, it's simply the orientation of the battery. If you go from minus to plus, it's a plus voltage. If you're going from the plus to the minus, it's a minus voltage. Remember, for a battery symbol, the little side is the minus, the big side is the plus. All right, so I'll start the outer loop right there where I got my mark. And we go with the battery, so that's plus 50. We're going with I1 through the 20 ohm resistor, so it's minus 20 I1. Then we go through R4 with that current, so it's minus 10 times quantity, I1 minus I2. Okay, and then we go with this battery, so that's a plus 20. Okay, and then we go with this current here through the 40 ohm resistor, so it's minus 40 times quantity, I3 plus I1 minus I2, and then I'm back to where I started, so this all has to equal 0. Now, at this point, we're going to do a lot of algebra. If you put all your like terms together, okay, and I'm not going to belabor all the steps, period, but if you put all your like terms together, all the I1 terms together, all the I2 terms together, etc., and then you move whatever doesn't have an I with it, the constant, which would be 50 plus 20, that'd be 70. You can also divide everything by 10. If you do all that, you get the following. 7I1 minus 5I2 plus 4I3 equals 7. Okay, so that's algebraically equivalent to any other answer you might get. Okay, so that's the outer loop. So we got one of our three equations we need that has our three unknowns in it. Then the next one I'll do is the top loop. Okay, so I'll do the top loop. So the top loop starts the same as the outer loop. The first two things are exactly the same, so I can just kind of copy that down. So we got positive 50 minus 20I1. And then from there, things change. So then we're going to go through R2 right there with I2, so it's minus 30I2. Okay, and then we're going to go with this current here, I2 minus I3 through the 10 ohm resistor, so it's a minus 10 times quantity I2 minus I3. And I'm back to where I started, so this all equals 0. I'm going to do the same thing here algebraically. I'm going to get, I'll put all the I terms together, move my constant to the other side. I'd also divide everything by 10, make life easier, and I get the following. 2I1 plus 4I2 minus I3 equals 5. So there's another equation, okay? And then finally, the only part of the circuit I haven't touched yet is this R5 part. Okay, so I could pick any loop that includes the R5 part. For this discussion, I'll pick the bottom right loop. So we'll do the bottom right loop. That will include that 20 ohm resistor there, the R5. Now for this one, I will start right here and go clockwise around that loop. So we first go with the battery, so it's positive 20, okay? And then now here, when I go through R5, I'm going against I3. So I'm going uphill, so I have to add. So this becomes a positive 20I3, okay? And then I also go against I2 through this 30 ohm resistor. So that's also going to be a plus, and it's going to be 30I2. So plus 30I2, okay? And then I go with this current through the R4, the 10 ohm resistor, so that's a minus. So we've got minus 10 times quantity I1 minus I2, and this all equals 0, okay? And then if I combine like terms like the previous two parts or previous two loops, I get the following. I1, I'll put a 1 in front of that, but it's just I1. Minus 4 I2 minus 2 I3 equals 2. Okay, so I've got that. Now, at this point, I've got three equations, three unknowns. There are a lot of ways that you could solve these three equations. So some of you can just literally put these in your calculator, and you know how to do that. And in my classes, I will actually talk about that. I'll give a helpful sheet on how to do that. There's a couple ways to do that in your calculator. If you want to do it by hand, though, you can also do Gaussian elimination, which I will really quickly run through. Okay, so just to kind of show you what that would look like. So your math teachers will love this. So what you do is you have these equations, okay? You write the coefficients down. So you have the I1 coefficient, the I2 coefficients, the I3 coefficients, and then the number on the far right. So for our first equation, it's 7, negative 5, 4, and 7. The second equation, it's 2, 4, negative 1, and 5. The last equation, it's 1, negative 4, negative 2, and 2, okay? And then what you might recall doing this in math class, if you're in this class, you almost certainly do this in a math class at some point. You like, so like for instance, I'm going to get rid of this and this coefficient. So if let's see here. Actually, I'm going to get rid of, sorry, keep the 1 there. I'm going to get rid of this and this. So I'm going to take this times negative 2 and add it to that. And then I'm going to also take this times negative 7 and add it to this, okay? and that'll get rid of those coefficients. I'm also going to take this equation and I'm going to write it up top here, so that way it's just easier to see. Okay, so if we do that, we have our 1, -4, -2, and 2. Okay, the middle equation, okay, which will be this one here, the 2 is now gone, right? Because we added this to that. The second term would be a 12. The third term would be a 3, and the last term would be a 1. Okay, so like for instance, you take this 2 times -2, it's -4. -4 plus 5 is 1. Okay, if you do the same thing to the bottom, to this equation here, I'm going to move that to the bottom now. You get 0, you get 23, you get 18, and you get -7. Okay, and then finally, I will take this second equation here and times it by -23/12 and multiply by that equation, or add it to that equation. So that way, that will get rid of this coefficient right there. That'll become a 0. And then your final result is 1, -4, -2, 2. You get a 0, 12, 3, 1. You get a 0, a 0. This becomes 12 1/4. And the last one becomes, and I got to get a little more room here, because now we're getting decimals. I get -8.916 with that repeating. Okay. So now that last thing is an equation. These are the coefficients. So it's 0I1 plus 0I2 plus 12.25I3 equals -8.916. Okay. So now we can solve, you have I3. You solve for I3, and you get I3 equals -0.728 amps. So by the way, we guessed wrong on I3. It's going the other way. And then you can go back and plug that into here to get I2. Okay. So if you do that, you get I2 is 0.265 amps. And so we guessed right on that one. And then I1, if you plug those into the top equation, you get 1.604 amps. So we guessed right on that one. Okay. And then once you have that, you can also find any of the other currents by doing the appropriate thing, like I2 minus I3 there and so on. Additionally, you can find any voltage drop you want now because you have every current everywhere. So for instance, if I wanted to find the voltage drop across R1 there, I would just take 20 times I1, which is 1.6, and you would get, whatever, just over 32 volts, okay? So you could find the voltage drop across any resistor by multiplying I times R at this point, now that you got all the currents. All right, so, and again, the math for solving these, there's a lot of ways to do it. You could use Gaussian elimination like I did. You can plug them in your calculator. You can literally just do algebraic substitutions and so on. Any of that stuff will work. So I hope that video was helpful, and thank you very much.